going to see that if you put the 60 above, you're going to end up getting the grade what? It should be grade C, okay? Just wait for it to load here. I'm running it online, so sometimes it will slow down a bit, okay? Because so elif is means else if, okay? It means else if, okay? But for Python we cut it and call it elif, okay? That's why. So we usually, if so you will find that in some cases you have many conditions that you want to check against, okay? So you'll take this, if this, do this, else if, else if, then else. Now else will come in when neither of the above have been satisfied, okay? So you'll find in some cases, maybe when you open your file in that assignment you are given, you may find this kind. So at least you know what this means. Okay, I think I've answered who was Pascal. Yeah, Pascal was asking a question, and you have seen that whatever is executed first, satisfied first, then the rest will not be executed. Okay. Pascal, is that okay?
Yes, it's okay.
Okay. So, okay. So if that's okay, then uh, okay, then okay, maybe another. Uh-huh. Okay. So this is done for the if. Okay. Uh, also, of course, we can you can have something similar. Okay. Uh, in for example, in other languages, just something which you call the switch. Okay. We have a switch. Okay. We have a switch statements. Okay, which we can use. Okay, but maybe I might. Uh, so we have this. Okay, so let me go back to, if you have if you want to practice, it's okay. You can also open in your machine and try. Okay. Okay, these I'm going to skip because they're just comparing identity operators, true or false, true. If type A is an int, if the data type of this one simply means if the data type here is an integer, which is true, type A is an integer, print true. Okay, so this will print true. Okay, else if it is not, the type, if this doesn't evaluate, if this isn't executed, okay, if this is not true, then this should execute. Okay, that's the meaning. Okay, so the else is like the other branch to execute what, in case the truthfulness, in case the condition, the resulting value is not true. Okay, the condition is not true. The things inside the condition are not satisfied per se. Okay, if the condition is not satisfied, the else is going to be executed. Okay. Yeah, so here I'm saying that if the data type of A is integer, print true. Yes, it is true, okay? If the data type of A is float, okay, now it would give us a false because 5 is not float. But if it was 5.0, it could be true because it is a float. Okay, for example, very good here, they're telling us variable B is holding a value 5.4, and they're telling us that if the data type of B is not int, print true. Yeah, it's not int because it is a float. Okay, so this should give us. So if you have to look carefully, the concept is that whatever is inside here, okay, we are meaning that is this condition satisfied. Okay, if it is satisfied, then this should print out. Okay, otherwise we print the false. Okay, so the key point you should take, if a condition is satisfied, okay, if this, let me call it, should I call it expression, this inside, if this is satisfied, okay, this should execute. Okay, whatever is under it should execute. If whatever condition inside here is not satisfied, then it will not be executed. The else branch will be executed. Okay, that's the meaning. Okay, yeah, so the condition inside here is executed. Okay, the condition inside here is satisfied. Why? Float this data type isn't int, it is a float. Okay, that's why we are having this statement inside this body being executed. Okay, why is this executed? Because this inside here, this condition inside here is satisfied. Okay, if this, think of it that if this condition is satisfied, do this, otherwise do this. Okay, so that is the meaning. Okay, so we are saying that if, okay, let me put it here, if condition is satisfied, if condition is satisfied, okay, that is what we are meaning here. If condition is satisfied, you do what? Do something. Okay, do something. Okay, otherwise do this. Okay, so that's the meaning. If condition is satisfied, okay, whatever is inside here, the moment it is true, it is true. Okay, you're going to execute whatever is under there. Okay, otherwise not. Okay, so that's the key concept around this. Okay, so maybe we can run some examples here. One more example here to show you what I mean. We have already seen that. Okay, so the simple ones, we are going to start with okay, so the other example which you saw, A equals to B, sorry, A equals to a 7 and B equals to a 10. Okay, now we have different things. We have we are going to first use a you can use brackets or you may not use the brackets. Okay, if A I'm going to show you something. If A is not equal to B, okay, we say print okay, maybe true. Okay, let me just use, okay, let me just true. Okay, it is true. Okay, now when we are not equal to, this is the meaning of not equal to. Okay, not equal to, this one is A equal to B, that's the meaning. Okay, now the moment this condition here is satisfied, okay, is A not equal to B, the moment this is satisfied, it's going to execute this. Okay, so saying that 7 is not equal to 10. This is the meaning, which is true. So this should print true, okay? So that is the meaning. Also, if I'm to say if A is less than B, it should print true. It is correct because this condition is satisfied. The moment this condition is satisfied, this, whatever is under here is going, under this if is going to be executed, okay? A is less than B, so this should be true, okay? Also, this one will be executed, okay? Because A is not equal to B. So we're saying that if this condition is satisfied, do this, okay? So that's the meaning. Once the condition is satisfied, it will print out, it will execute the statements in the body, okay? Okay, so that's the meaning. Okay, two-way decisions, okay? We have already seen the if else, okay? If condition satisfied, execute the statements, otherwise do the else bit, okay? So notice how we attached an else clause onto an if clause to come up with what we refer to as a two-way decision, okay? So this is a two-way decision. We have already done that, okay? So I will skip that. It means that if that is true, if the condition is satisfied, execute that. Otherwise, use the other leg, okay, the other branch. Execute the everything that is in the other side, okay, that other branch, okay. So these are like branches, okay. The yes and the no branch, okay. So the following line will make we'll make the math library be available to us, okay? So you'll find that in some Python files, you see some, in the preamble, there are some things that are there, okay? From this, import this, import this. So importing, like I said, you'll find that there are libraries that there are things that are already done for you. So you yourself, you don't have to like write the equations yourself in the program. You just borrow and reuse because like you want to calculate what average or what, you'll find that the functions are already there. Maybe you call it AVG and then you plug in your data sets, okay? So that is the meaning. For when you are importing, we want to make use, okay, like calculating what? The area of a circle, what? All those things. They are already done for us. Calculating the square root, okay? Okay, so we have here an example where they have written a Python function, okay? So the keyword for when you want to write a Python function, the def, okay? And they're calling the function roots QE, okay? So this is a function, maybe it's going to do something, let's see. Okay, this function first, they're saying once it is called, it is going to print, this program finds the real solutions of a quadratic, okay, this one is print with empty brackets, is just going to leave an empty line on the console. Okay, so now they're saying input, enter a value of a coefficient A. Remember what we talked about, the eval. So someone is going to enter a value, but that value should be an integer, okay? That's why we use eval. Or you can use int. But because someone may enter a floating point, that's why we use eval. So eval just takes whatever you give it, okay? And it will convert it to either integer or float, okay? Depending on what you have given it. Okay, also we are taking another value and the C, okay? So this one is just, we are going to, it's going to calculate first the quadratic equation for the values that are going to be given, okay? So you can see that in the math library, we are importing sqrt, okay? Remember here, we said import math, okay? Now I've said that you will find that in most of these libraries, even as you have seen in that assignment that you are going to do, you're going to see that there are a lot of things that are being imported, and because you're going to use them, you don't need to think about and or try to hard code the equation. You just reuse. Okay. Now in the math library, the square root is already done for you. Okay, so you just call it math.sqrt. Okay, so this function can calculate the square root of the given of this given numbers which are going to enter here, different values. Okay, and of course that is what you are going to end up Okay, then you're going to you're going to calculate this quadratic equation. Okay. Okay, of course, you're going to call the function, and the function is going to be executed to executed. The body of the function is going to be executed once called. Okay. Okay. This program finds the real solutions to a quadratic. Okay. So here they're saying that, okay, when you execute this program, it's going to give, they're saying, math domain error. Okay. Okay, let's see why we have an error from this result. Okay, so here they're saying that root in module, root equation. Uh, so the square root function is unable to compute the square root of a negative number. Okay, so if it returns, say, a negative number, it's not okay. So how do we avoid this problem? Once we call the square root function, we can first compute the discriminant. Then we can check if it is negative, if the result is negative. Okay, if it is negative, we can print out that the equation has no real roots. Okay, so here we are bringing in the if statement here. So they're saying that here this program originally was to calculate the different roots, okay, using, of course, this the quadratic equation, okay. But they're saying that this square root function, the way it is designed, in that it cannot calculate the square root for, say, the negative the negative numbers, okay. So they are saying that at this point, when we return the s root value, we can check if it is negative or not, okay. We can put in an if to check, okay. We can check if it is negative using an if statement, okay. So this is just an example, okay. So they put here discriminant, okay. If the result is less than 0, negative, okay, we say the equation has no real roots. Otherwise, we can go ahead and calculate the roots, okay. Okay, so that's you can see that the if statement can come in so many ways, okay, for you to check the conditions, okay, before you proceed. Okay, so we have finished this first bit. So let's take a break and do the other. We open another lecture, which is decision structure part 2. Okay, so we can take a little break for, say, 5 minutes. Okay, so let's move. Okay, I had already introduced these multi-word decisions, but okay, we can go through them quickly. Okay, we were mainly using the two-word decisions, okay, of if else, okay. If the condition is satisfied, execute the statements, otherwise execute the other statements on the other else branch. So what happens sometimes if we need to make, say, a five-word decision, okay? So that is why we are going to end up having multiple else if statements, okay? So the if else structures, in this case, if you have a five-word decision, we are going to have four nest levels, okay? Where we have the multiple else ifs and then we have one else if page, okay? So is there a way we can do this? We have already seen, okay? We are going to do the if, the else if, or what we call the elif and else, okay? So here is how the if else if form looks like, okay? So you're going to have a condition. The other condition we had was that we had a student who had marks. That student had scored 75. But again, say we wanted to grade the student, okay? If they score more than 75, maybe they get an A, they get a grade A, okay? If they score still, if they score above 70, okay, they get grade B, okay? Now that they're at 75, they're going to they're going to get a grade B, okay? If they score so that is what we have been looking at, okay? So you can have multiple conditions you want to test against, but once one is satisfied, you're going to jump out of, you won't execute whatever follows, okay? If all the above conditions are not satisfied, then the else will be executed, okay? So else clause is optional, okay? Sometimes you find that it is omitted in some time, in some, if there is nothing it's going to do, okay? Like you can have an if alone, the if can stand alone, okay? So the else is only included if you have things that you want to do in there, okay? Okay, it is if you don't have any statements that you want to execute, okay? So the else, sometimes you may eliminate it, okay? Okay, okay, maybe this, yeah, I don't want to use this example because we have already used the other example of the grade or the marks, but it's the same concept, okay? So here they're saying if the resultant value is less than 0, this should be executed. If it is equal to 0, then this should be executed. Otherwise, this should be executed, okay? If neither of the above uh, is satisfied, okay? So that's the meaning. So sometimes you may have multiple separate or unique conditions that you want to test, okay? Either one of those that may come out to be true, okay? So you want to check against that, okay? Okay. Because you may not like end up combining all of them into one single condition, okay? Because they are unique in their own way, okay? That's why you will have multiple conditions, okay? Any of those can be an outcome. That's why you'll have multiple conditions, okay? Okay, I think largely this example is for the quadratic equation, but again, the one that I gave you for the max is enough, okay? So that's why I'm just skipping this, okay? Okay, okay, again, it's the same example. I'm just skipping through it. I'm just skipping through it. Okay, we have another one here. Maximum of 3 numbers, okay? Say we assume that someone is going to enter 3 values, okay? X1, X2, X3, and then we are going to compare the value in the first value in X1, if it is greater than or equal to X2 and this. So remember our conditions, okay? If the left is true and the right is true, that's when it will be true, okay? For the AND operator, okay? So we can't have if both are false, then it's going to be false, okay? Okay, so this condition can only be satisfied if our resultant is true, okay? Okay, so I think we can run if you have your computer, you can get it and then we run this example, okay? Okay, they are saying that, just escape this. Okay, they're saying that def, maybe let me just say, let me call it comparator. Okay, we are going to be given yeah, we want to let our user to enter 3 values at once, okay? Last time in the example we used, we were just using 1, okay? But here they're going to enter 2 values, 3 values, okay? Okay, then eval. Okay, so here we want to compare. Let me just go back to the file. If x1 is less than or equal to, okay, they're saying if it's x1, x1, they're saying less than equal to x2. So these are case sensitive, so you have to maintain their if it's uppercase A, lowercase a, they are case sensitive, so you have to maintain them. And x1 less than equal to x3. Okay, you do something else if yeah, we're going to do something here, else if x2 and x1, x2 less than x1, and yeah, they're saying that max equals to x1. If the next condition, if the condition, this condition is true, then we shall have max equals to x2. Otherwise, if neither of those conditions are correct, we simply say variable here max equals to x3, okay? Okay, we are saying that, okay, print the just value is we are finding the maximum of 3 numbers, max. Okay, so here now we are going to take we're going to take three values. So the first one here, remember what we said about the and. If this condition here is true and this condition also here is true, it means that this is going to be executed, okay, because it is true, okay. The moment this is false, then it will not be executed. Then we have another one. If this condition here is true and this condition also here is true, then this is going to be executed. Otherwise, this will be executed, okay. So the maximum you're finding, say the maximum of three numbers, okay. If someone enters three numbers, which one of these will be correct, okay. So if I have 43 56 and maybe a 1, wait, 12. No, okay, maybe I need to separate them. 45, 67 and a 1. Okay, so here I think the largest value is a 67, okay. So which is x2, okay, because it was the second value. So the largest value is 67, which is coming in as x2, okay. So x2 is the largest value here, okay. Okay, so let us first prove here, okay. The first value x1 is 45, okay. Is 45 greater than or equal to 67? No, okay, false, okay. So here false, okay, because x1 here is, according to what I've input, okay, x1 is 45, x2 is 67, okay. So for the first condition here, 45, okay, is 45 greater than or equal to x2? So immediately this is false. The and will, this, we don't even need to look at this, okay, because this condition can only evaluate to true if both of these are true. So the moment the first one is false, we forget about even the rest of the condition. So when you come down to the else if here, you'll see that 67 is greater than 45. And at the same time, 67 is greater than 1, okay? That's why this will be executed. So the second value, x2, which is 67, is what will be executed, okay? So that is, so this is, so you can see that sometimes you want to test the different conditions, you want to test them, and then that's why you'll have this kind of structure here, okay? So we are building onto what we have already learned, okay? So this is a function, but this function calculates the maximum of three numbers, okay? And we are letting the user to input the numbers that they want to compare, okay? Okay, now here we are taking three numbers, okay? But as you can see, these variables here, each will hold one of the three numbers, and we are using, when we entered them, separated them with commas, okay? And then we can do this. So this is okay here, okay? Any questions here? And if you have your laptops, have you run this? Anyone has a problem so far? I would like to hear from those, especially those who maybe you don't have any computing background. If you could tell me, how do you see, or how are you getting along with what we are learning? I hope it's not very difficult.
Yes, Prof.
Okay, it's going well.
When you speak, it looks like it's really it's straightforward in terms of what you're doing, and you can see that it is okay. But the proof of the pudding is really in the eating. Yeah, I think we need to try it out once or twice, then we see whether we can follow the procedures,
Yeah, because
especially.
what I wanted is that if for this class I was urging members to, you just be on your laptop, you try out, okay? So the best way to learn this is not to look like if we are trying out, we need to try out together so you can see the result. Like now I can say, okay, I want maximum, I want this one. Okay, maybe I'm going to give the value that I'm going to enter the third to be maybe the greatest. Okay, so you can test out all these different conditions to see which one is suitable. Sorry, I cut you short. You can continue. Okay, so maybe I'm going to go just line by line here. So previously, we were only taking one value. Okay, someone can enter a value by themselves. Okay, but now since we want to compare the maximum of say 3 numbers, okay, we are going to prompt the user to input to enter 3 values. Okay, so when we are entering those values, we are going to separate them with commas. Okay, such that they come in this format. Okay. Okay, so that is what we mean here. Okay, so here, for example, if someone enters say 100, we are going to separate with a comma. So that means x1 is going to have 100, x2 is going to have 65, and x3 is going to be 80. Okay, so this is the meaning here. Someone is going to enter 3 values, and we have separated them by commas. Okay. Okay, so 100 by on the look of things here. Okay, on the look of things here, it means that x1 is what? Is 100. Okay, x2 is what? Is the one which is now 65. Okay, and x3 is the one which is what? 80. Okay, and what is the meaning? It means that x1 is the maximum one. So when we execute our code here, you're going to see that this condition, the first condition, is the one most likely to turn out true. Okay, in fact, it should turn out true because what is the meaning? That x1 is 100. Okay, x2 is what? 65. Again, remember what we said, that x1 is 100, and the value which I entered for number 3 was 80. Okay. Okay, so what is the meaning? 100 is 100 greater than or equal to 65? True, it's greater than. And is 100 greater than 80? True. Okay, so maximum value is 100. Okay, which was our x1. Remember, x1 when I entered it is 100. Okay, and x2 when I entered the value it is 65. Okay, and x3 when I entered that value it was 80. Okay, so I'm doing the comparisons here. Okay. Okay, so that is the idea. Okay, so this is going to be true. Okay, and also this is going to be true, meaning that this condition is satisfied. Okay, so this should execute. Okay, so our maximum value of the 3 values is going to be 100 here, the ones that I entered. Okay. Okay, I think this is clear. Okay, so let me put back the way it's supposed to be. x1, x1, x2. Yeah, so for those who are maybe new to the language and everything, in most of the cases, you just have to practice and try out the many the many possible outcomes. Okay, so you can just play with it and understand. Okay, like that. Okay, so this is okay, right? So if I run this, I think, is it still running? Yeah, okay, I didn't enter. Okay, enter. When I enter, the largest value is 100. Okay, like you have seen, I was explaining it. Okay, so this will be executed because this has evaluated to true. And the moment it evaluates to true, these others will never be executed. Okay, the first if condition that is satisfied is what will be executed. So all of this is like dead. As long as this is executed, the first condition met is satisfied, the rest will not be executed. Okay, very good. So, yeah, I guess, uh, um, okay. Uh, what else? What else? Yeah. Okay, so we have finished this. We have finished this one. This example, we have run it. So this program uses a strategy that can be referred to as compare each to all. Okay. So it's difficult to scale the program to more than numbers, say 10, 100, or even more. So the following strategy will make the code very long, complex, and prone to errors. Okay. Let's see what they mean. They have another version to simplify this. Okay. Where they do that and nest. Now this is very important. Okay. Now, you will find that in some cases, you don't want to make your program very long and complex. Okay. Sometimes you want to make sure that if just even the first condition is true, you can put in place another condition under there. Okay. What do I mean? You are graduate students, right? Let me say, no. Let me see. What example can I use? What example can I use? If yeah. So also when we talk about like performance, program performance, sometimes you want to make sure that your program is optimized. Okay. The moment the first condition is false, you shouldn't proceed even to look at the second leg of the equation. Okay. So sometimes you may have those kind of conditions. Okay. But also you may have conditions where you want to nest an if inside another if. Okay. Should I call it a specialization? Mm, uh, yeah, sorry about that. It was a network issue on my end. Let me just okay. So what can I say? What example can I give? So I was trying to find an example, say for a car. Okay. So a car can be yeah, because I think the different specialization. Okay. You can first meet the first condition. Maybe maybe this is a what example can I use? Okay, this is a Subaru. Okay, then you have another condition saying that is it a manual or automatic car? Okay, so you are there is that general, you have that general condition, but again there are conditions under there. So you go breaking down your conditions further and further and further. Okay, so in some cases you may find that to improve your program performance. Okay, the moment the first condition is false, you don't need to look at the other leg of the condition. Okay, so this is what I mean here. So here we are saying that in this kind of condition, what is going to happen is that this is going to be checked and this also is going to be checked. Okay, however, why should we know that for example for the and, okay, and can only be true. For example, this condition can only be where we have an and. We know that it can only be true if either legs are true. Okay, if this is true and also this is true. Okay, now why should I check this when this is already okay? If this was false, for example, why should I go ahead and check this condition here on this other right? Okay, because eventually it won't satisfy this. Okay, for in some cases we want to nest what we call, you can nest the if statement. Okay, if the first condition is satisfied, you needn't check the rest. Okay, or you can go ahead and further check it. Okay, so the example here is that the moment x1 is greater than x2, okay, the moment x1 is greater than x2, at least we know, okay, maybe we can now further check it against x3, okay? But the moment it is less than x2, we don't need again to check it against, okay? So we shall jump out of here. So the moment this condition is satisfied, okay, we can go to these other blocks, okay? However, the moment this first condition, remember, the moment this is false, okay? Let me use F. Oh, let me use, the moment this is false, is not true, okay? The moment this is not true, I don't need to look into this block again, okay? I'm going to go direct to the next else if, okay, or else, depending on what's there, okay? So sometimes you want to optimize your program, but also sometimes you may find that there is a condition under another condition, okay? So that is it, okay? Okay. Uh, okay. So it's just that what, okay, we know that the condition for you to get a driving permit in Uganda is you have to be above 18 years, right? Okay. So it is true that this boy Sam is 18, okay? Sam is 18, okay? So we say if okay, let's say if Sam is maybe above 18, okay? Okay, we first check against the age, okay? For you to drive, okay? Then we say if has driving permit, okay? If has driving permit, can drive, okay? That's the idea, okay? This is just a small pseudocode, okay? So here, the very first condition for someone so this person, for you to eventually drive, okay, there are things that you have to meet. Number one, be above 18 and have a driving permit, okay? Now, the moment you are not above 18, you cannot be given a driving permit, okay? You cannot be given a driving permit, okay? Okay? Or actually, this condition should be maybe get driving permit. This one, okay? Get driving permit, okay? So you can see that in some cases we don't want to even further check, okay? But also we also the only way that we can proceed to the other condition is if the condition above is satisfied, okay? So that's why sometimes you find that you will have some nested, you'll find an if statement inside another if, okay? Like you have this overall condition and you have another small condition under there, okay? This person is above 18, okay? We assume that the moment they have a driving permit, they can drive. If you don't have, yes, you can be above 18, but you don't have a driving permit, okay? So else, okay? Else cannot drive, okay? On the streets, okay? Okay? So the first condition, be above 18. Do you have a driving permit? Yes, you can drive on the streets. Otherwise, you cannot drive, regardless of the fact that you are 18. You are above 18. You are not allowed. Do you understand this? So you find that there are ifs under ifs. Okay, there is a if statement inside another if statement. It is nested under there. Okay. Do you get this explanation? So there are two ways. You find
Yes.
that sometimes there are conditions and another condition, but also sometimes you want to quickly improve the performance of your program. Okay, because you know the logic that the moment this is correct, okay, I don't need to execute this. Okay, sorry, the moment this is false, okay, I don't need to execute whatever is inside here. Okay, okay, like here, the moment Sam is say, maybe if there is another person who is maybe 15 years, I'm not going to bother to execute this because they don't satisfy this first condition. Okay, now there is satisfying the first condition, but you don't satisfy the inner conditions. Let me call them the speciality or specialization, kind of like that. Okay, so you can think of it in that way. Okay, so your if statement can come in those. You can have if statements under if statements depending on the situation. Okay. Yeah, do you get this explanation?
Yes.
Okay. Yeah, so the previous program, the moment I know that the moment X is the moment this first condition is not satisfied, okay, I just proceed. There's no need to go to check whatever is coming in after there, okay. But however, the moment this bit is satisfied, I can go further and check another condition under there. If it is satisfied, well and good. Else, not, okay. So this is a simple way. This is very good, especially for performance. Okay, so sometimes you want your uh, 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 we call it the clock frequency. Okay, the instructions, the rate at which your CPU executes your instructions. Sometimes your program performance may slow down because of the way you wrote your program. Okay, but sometimes you can optimize performance, okay, by having better conditions. Okay, you write better programs. Okay, so that's why sometimes you will need to do this kind of measures. Okay, this program is the same as the previous one. Okay, this is the same as the previous one. Okay, but here they're telling us the danger that you can make very long and complex. Okay, when you add so many things together, you add many expressions together. Yeah, now imagine here there is an and here and another and here, then another and. Okay, it may become very long, complex, or hard to read, or even hard to follow. Okay, and also maybe you're going to increase your execution time, your CPU execution time. Okay, because why should I go ahead and check these other conditions when this first one is enough? The moment this is true, it's maybe I can continue to further check. But the moment it's false, there's no reason for me to keep checking the other conditions because I know that at the end of it all, it is still going to not to be satisfied. Okay, so okay, so a simplification of that program, we first check the moment x1, the value of x1 is greater than or equal to x2, we go ahead and execute the we try to go into the other condition, then we do that. Else uh else here we know that x3 will be given will be the greatest among the values. Okay, why is this even true? So we have x1 less than 2, greater than equal to 2. We know that, okay, if x1 is 100 and x2 is 65, this is satisfied. The next thing is we know that, okay, x1 is even already greater than x2. So it means that if I compare x1 to x3 and it is still greater, it's going to be the largest. Otherwise, maximum of this is going to be x3. So x2 is already out of the loop, okay, because x1 is already greater than it. Okay, so you can see this. So else, the other side of the else is trying to tell us that the moment x1 is not greater than or equal to x2, we are going to execute this. Okay, and we don't now here by default. By default, the moment this is not satisfied, it is obvious that x2 is greater than x1, not so, or is equal to x1, and then we can compare it against x sorry, is greater than. The moment this is not satisfied here, it means that x2 is already greater than x1. So this else branch already, the next comparison is to directly compare with x3, okay? So the moment x2 is greater than or equal to x3, we can give the maximum as x2, okay? Else max will be x3, okay? So you can always follow the logic of your program and optimize it optimize your performance. Okay. Okay. Here the condition, they're saying that this condition means that if x1 is greater than or equal to x2, if it is true, that this is the flow chart for the other program. Okay. If this is true, then we again check x1 against x3. Okay, of course, if x1 is greater than x3, then our maximum is going to become x1. Otherwise, it's going to become x3. Next one, we are going to compare x2 and x3, the other side. Of course, this comes in when this condition, the moment this is not satisfied, okay? The moment this is false, we are going to execute this other leg, okay? This other branch. Like that. We shall now, of course, we are saying that if x2, comparing x2 and x3, x2 is greater than equal to x3, then our maximum value should be x2. Otherwise, it's going to be x3, okay? Okay, so that is the simple flow, and then our program will eventually end here, okay? Okay. Okay, they're saying still this strategy makes it more difficult to scale the program to more numbers, say 10, 100, or even more. Okay, let's see here with an example. Okay. Okay, so here this is another version of the program where they're saying that this program uses a strategy that can be referred to as sequential processing. Okay, so here the max value immediately, maybe they start with x1, okay, and then we compare the rest against x2 against max. Okay, okay, if initially our x1 is given as the maximum number, okay, initially, okay, we are going to check against it with the other numbers, okay. So x2 is going to be compared with x1 here at first, okay. Now the moment x2 is greater than max, it's going to become our maximum number, okay. So x2 is going to become the max, then we compare the max against x3, okay. So again, always it's all about optimization, okay. You can always check against the different conditions, okay. And here the else, we don't write the else in here, okay. Here else is not written, okay, simply because there is nothing over there, okay. Like it is there are no statements under there, okay. So you'll find that for some if conditions you don't have an else, it is there but it is like dormant, should I say. It's not doing anything unless you have statements written under it. Okay. Okay, so they're saying that this version can allow us to scale to other programs, okay, if they have many numbers. Okay. So after this, we are going to move to loops, okay, the for loop, while loop, okay. Then after, we are going to move to the data structures, the list, the tuples, then we finish, and we can cover that in the next lecture. Okay, so maybe next lecture may be our last for the Python introduction, and then I take you through the like, for example, I saw you were given that assignment, okay? But so I want us to go through that, understand the meanings, how do you read a file, how do you go through the different steps and so on, okay? So try to familiarize yourself with what we have already done, okay? The notes I have that are there in the module 1, they are very detailed, okay? So you refer to those Python notes, okay? And practice, okay? So I want us to at least to wrap up next week with most of these introduction things, then we can go to the actual work, okay? Okay, so Yeah, so here we're saying that in particular, we can easily write a program that computes the largest of n numbers by folding our algorithm into a loop. Okay, so we're going to show a loop. A loop basically just iterates over a certain number of items, or it has a condition for which it will later terminate. Okay, or unless it is an infinite loop that won't terminate. Okay, so a loop is a device that tells a program to do the same thing over and over. Okay, repeatedly. Okay. So this we shall see in the next lecture, okay? So we're going to look at for loops, okay? So for I in range this, it means that this ideally means numbers within the range of 10, okay? 1 to 10, and then you can print hello, okay? So this will print hello 10 times, okay? For I in range, for each instance of the number of a certain index, okay? We're going to print this 10 times, okay? Do this for 10 times, okay? Okay, so next we are going to look at these loops, okay? So for this, do that, okay? So a loop allows you to do multiple things several times, okay? So like this loop here is going to allow us to do this here in brackets for this number, for a certain number of times, okay? Execute this for a certain number of times, okay? So in the first run, it will be like it will run this and then go back, okay? And then run this and then go back, okay? And then run this and then go back and then run this until this condition is not satisfied, okay? Or it has been satisfied, okay? Or it has reached, okay? So that's the beauty. So the loop allows you to do multiple things for many times, okay? So we're going to look at loops in the next class, okay? And you can see that we are building on to each onto everything, okay? So you could have a function. So you see, we have what are some of the key things we have learned? We have a function here. We have if statement in here, or now we are going to add on a loop, okay? So you find that your program is going to have all the things that we have been talking about, okay? So you can do this. It means that do this for a certain number of times, okay? Repeatedly, okay? So we have the if condition. If it's satisfied, you do this, then you go back, okay? Do the same thing over and over for a certain, until the termination criteria is reached. Okay. Okay, so let me see this design. Okay. Okay, so this is what I've been saying, that there are always better ways to solve the problem. You can always write your program very smart, very good, but again, like I said, performance is very key, okay? Performance, okay? So you have to care about how you write your program. Okay. Also, they're saying do not reinvent the wheel. You can use Python existing libraries, okay? We have seen if you want mathematical functions, like now over there in your work for machine learning, you're going to use libraries like the NumPy. NumPy has so many mathematical related functions that you can reuse, okay? So most of the things have already been done, okay? You just need to know how to apply them and use them. Okay, so we are done with the decision structures, okay? The if, else, else if, and so on, we are finished. We are going to move to loops and the data structures, okay? At least that would be good enough for us to start with our work, okay? Okay. Okay, I'm going to end here. I'm going to end here today, and yeah, if you have any challenge, you can always reach out to me, okay? You can always reach out to me on my WhatsApp. Okay, so let's finish here. Let's end here today. Thank you very much.
Thank you, Prof.
All right, all right.
You didn't go.